Hello everyone and welcome back to another video. My name is Dylan and today we're taking a look at the 2016 SATs paper 2 for maths. This is the first reasoning paper that was given back in 2016 and this is the real test that children who were in year 6 in 2016 took. So this is 9 years ago now. So the children who took this test are now adults, which is insane. But without further ado, let's carry on because Hayden has already gone through paper 1, which is the arithmetic. I'm going to take a look at every single reasoning question now and see exactly how to answer them. Let's see if you can too. Question 1. Ali puts these 5 numbers in their correct places on a number line. Write the number closest to 500. So in this case, the best thing to do is to write the difference between 500 and each number above. So in this case, let's write down 11. 499 is only 1 away. I'm going to guess that's going to be the closest, but let's just make sure. 502 is 2 away. 555 is obviously 55 away. And 455, you might think, oh, it's 55 away. No, we'd have to add on 45 to get to 500. So the number closest to 500 is 499 because that is only 1 jump away from 500. But this is why it was really important to do every single piece of work at the top because now it wants the number furthest from 500. In this case, it's going to be 555. So well done if you got those. Question 2. Put the houses in order of price starting with the lowest price. This is place value and 1 has been done for you. So we started with B is second. Right, let's take a look then here. If B, we'll get rid of that one. We want to start the lowest. So out of these ones here, only E is in the tens of thousands. The rest are in the hundreds of thousands. So I'm going to write down E at the bottom here. So I'm going to get rid of E. Now 119 was next. Cool. What's next? Well, we've got 130 on all of them. So we have to look in the thousands column. And we put C next because that has 0 thousands. And then between D and A, we have 1,000 or 5,000. So D is the next smallest. And then we finish off with the most expensive house is A. Now, you can tell that this is written 9 years ago because I don't think any houses exist which are this price these days. Let's down then to question 3. Write the 3 missing digits to make this addition correct. Something plus 4 equals 5. Straightforward there, it's just 1. Here's where it becomes more complicated because 5 plus what equals 1. And you might be thinking, that does not make any sense. Well, that's because we don't want it to equal 1. We just want a 1 in the ones column. So therefore, it's actually going to equal 11. So writing this 1 in will be really helpful. 5 plus blank is equal to 11. Well, then we know that's 6. And now we can do 1 plus 4 is 5, but we've got the 1 from the exchange we had to write in. So this is going to be a 6 down here. You can really see how that exchange affects the difficulty of this question. The first one was rather easy. Then we really had to think about the rest. Question 4. This table shows the number of people living in various towns in England. We have Bedford, Carlton, Dover, Formby, and Telford. What is the total number of people living in Formby and Telford? This is a case of just adding up these two numbers. So this could be an arithmetic question, but the way that they've put this into a reasoning paper is that it's embedded in statistics, it's embedded in a word problem, as you can see here. So let's write it out nice and neatly, and we're going to make sure we line up our digits because we have a 6-digit number, adding a 5-digit number to it. So once we've mapped all this out like this, we have an 8 in the ones column. I'm going to write it straight into the box. 4 plus 7 is 11. So I'm going to write a 1 in the tens. I'm going to exchange over my 1. 6 plus 4 is 10. Add 1 is 11 again. So again, I'm going to exchange over a 1. Guess what? 6 plus 4 is still 10. Add the 1 is 11. So I'm going to write again over here with another 1 down below. 6 plus 2 is 8. Plus 1 is 9. So I'll put a 9 there. And then finally that 1 drops down. So we have 191,118. So many ones it can become confusing. Do you know what I would do in this case? I would just write it here and then take the 3 seconds that it takes just to do your exchanging over, okay? Bring the 1 down, write it over there. What is the difference between the numbers of people living in Bedford and in Dover? So we need to look at Dover, which is going to be 34,087, and Bedford, which is 82,000. To find the difference, it's just subtraction. So this really is basic arithmetic, but it's embedded in a word problem, which makes it qualify for the reasoning paper. 8 take away 7 is 1. 4 take away 8, we're going to have to do some exchanging here. 14 take away 8 is 6. 3 take away nothing is 3. 2 take 4, again, one more bit of exchanging. 12 take away 4 is 8. 7 take away 3 is 4. 48,361 is the answer. Basic arithmetic embedded in a word problem. Classic. Write each number in its correct place in the diagram. This is a Venn diagram. Prime numbers, even numbers, square numbers. So we're going to go through and check each number. 16. Is that a prime number? No, it has more than 2 factors. Is it an even number? Yes. And is it a square number? Yes, because 4 times 4 is 16. So it's not prime, but it is even and square. So 16 is going to have to go here where these two overlap. 17, is it a prime number? The answer is yes. There's only two factors for 17, 1 and 17. Is it an even number? No. And is it a square number? No. So 17 is just a prime number. We put it in there. 18, is it a prime number? No, there's multiple factors. Even number? Yes. Square number? No. So 18 is just an even number. Now let's think about 19. Is 19 a prime number? Yes, only has two factors. Is it an even number? No. Is it a square number? No. So 19 would go over here. Just got to be systematic with them questions. This diagram shows a shaded shape inside of a border of squares. So we don't have the squares, but we can use the outer square lines to help us with this. Our job, up here, is to draw the reflection of the shape in the mirror line. So imagine this is a mirror. So what we have to do, the best thing to do here is to map where the points would meet on the line. So here is 2 across, so we're going to map 2 across here. And this line has a gap of 2, and then we have another line here. So we must end up with a gap there. And then if we go down, this one will be reflected over here. This one's reflected down in this corner. And then we get one along. And then finally, we don't have anything across the bottom. But what we do have are these lines starting here. Now, let's look at the lines. This line, we'll start with this line here, goes up to the top point here. So our lines here are going to have to join. Excuse my line drawing. You will have a ruler and a pencil, so you'll be much neater. Now we can see how this line is a reflection of this line. And then the line below it, we're going to start at the bottom, and we're going to go to this point over here, which is reflected there. So I'm going to draw a line from here to here. Awesome. What you can do if you want to is just draw the outline. So we've reflected in that part now. Let's look at this part. Where does this line go? Well, it goes down to this one, which reflected is this one here. So we're going to draw a line all the way up like that. And then here goes up to this one. And we can draw the outside just to make sure. What's really important is you are mapping either the points or the lines and doing them one at a time. This line maps with this line, for example. And also, of course, using a pencil and a ruler. Question 7, write the missing two values to make these equivalent fractions correct. We're going to start with this one as our base fraction in the middle. How do I get from 8 to 4? Well, I divide by 2. So I do the same to the bottom, divide 12 by 2, I get 6. Over here, how do I get from 12 to 3? Well, I divide it by 4, do the same to the top, and we get 2. 2/3 is 8/12 is 4/6, just equivalent fractions. Circle two numbers that add together to equal 0.25. You might see 0.2 and 0.5 and think, cool, 0.25. No, look what happens when we add them. If we line up our digits correctly, 2 plus 5 actually gives us 0.7. That is not correct. What we want is 0.2, and then we're going to take 0.05 because that shoves the 5 down to the hundredths, which is perfect when we add it up. 5 hundredths, 2/10, and we have 0.25. Very easy to fall into a trap there. Even 23 plus 2, you might think, well, that's 25. That's not how it would work. It would be 0.43. Question 9. 6 pencils cost £1.68. 3 pencils and a rubber cost £1.09. What's the cost of a rubber? Well, the first step is to work out how much a pencil costs, and we can do that using this top set of data here. If £1.68 is 6 pencils, we take £1.68 and we divide by 6 because that will give us the cost of 1 pencil. 6s into 1 obviously don't go. Put the decimal up. And the 1 gets exchanged. 6s into 16, there are 2 6s are 12, and we have 4 left over. 6s into 48, that's going to be 8. So we have 28p per ruler. Now that we have that information, we can work out not per ruler, per pencil. Now we have the information, we can do 28 multiplied by 3, because that will give us how much these 3 pencils cost. 8 3s are 24. 3 times 2 is 6, add that on, it's 84. So 84 pence. And we know the remaining rubber must cost the difference between 84 pence and £1.09. So we take 109 pence, we take away 84 pence, 9 take 4 is 5, 0 we can't do, exchange it over, 10 take away 8 is 2, and we have 25 pence for the rubber. The rubber costs 25p and the pencils cost 28p. But the question is, what's the cost of one rubber? We had just had to work out the pencil to get there. Question 10. Each diagram below is divided into equal sections. Shade in 3/4 of each diagram. Now the first one is straightforward. There are 4 parts, so you simply shade in 3 of them. Nice. But here we don't have 4 parts anymore. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. So you need to think of the equivalent fraction of 3/4 if there were 12 as the denominator. So we multiply the bottom by 3 to get 12. 4 times 3 is 12. Do the same to the top, we get 9. So we need to shade in 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And over here again, it's out of 8, which if we were to find an equivalent fraction for 3/4, we double the bottom, do the same to the top, we get 6 eighths. 1, 2, 3, 4, 5, 6 to be shaded in. Again, 3/4 might be easy to visualize of leaving a quarter just like that. But that's how we answer that question. Question 11, a packet contains 1.5 kilograms of oats. Every day, Maria uses 50 grams of oats to make porridge. How many days does the packet last? Now, we'll notice this is in grams, and we notice this is in kilograms. First job would be to change 1.5 kilograms into 1,500 grams. And we have to know that a kilogram is 1,000 grams. That's a fact we have to know. The next thing we have to do is figure out, okay, how many 50 grams can we fit into here? Well, firstly, I would be thinking straight away, 2 lots of 50. So 2 servings for 2 days would be 100 grams. And I can fit 15 lots of 100 into 1,500. So I've got 15 lots of 100. And I know 100 is 2 portions or 2 days. So I can do 15 lots of 2 days. And that gets me 30 days that I can fit into my oats to get that many days of porridge. So a whole month in lots of respects. Not for some, because some months are 31. N equals 22. What is 2n plus 9? Well, in this case, when we have 2n next to the number like that, we just multiply it by 2. So this would be 44 plus 9. 44 plus 9 is 53. 2q plus 4 is 100. Well, let's work backwards to figure out q. The way we do this is we take away 4 from both sides to maintain balance. And taking away 4 here gets rid of that plus 4. And taking away 4 here gets us 96. So I have 2q is 96. Then I'm going to divide both sides by 2 to make sure this is just now q equals. Divide this by 2 and we get 48. So in this case, q is worth 48. And if you wanted to check, you could put it back in. 2q, so 2 lots of 48 is 96, plus 4, yep, that's 100. It works. Question 13. A stack of identical boxes, 20, is 140 centimeters tall. Stefan takes 3 boxes off the top. So how tall is the stack now? It's clear, hopefully, that we need to figure out how much one box measures. So if we have 140 and we divide it by 20 blocks. Now, a way to do this more easily would be to take 140, divide it by, and then use factors of 20. So I'm going to divide it by 10, and then I'm going to divide it by 2, because I can split 20 into 10 times 2. So I divide by 10 and divide by 2, it's the same thing. 140 divided by 10 is 14. Then I've just got to divide that by 2, and that means it's 7 centimeters per block. Stefan took off 3 boxes. So 7 times 3, times table knowledge here, is 21. So we need to do 140, take away 21, and we're left with 119 centimeters tall. Or in other words, 17 blocks that are 7 centimeters high. Super. Question 14. Write all the common multiples of 3 and 8 that are less than 50. So if we think about the common multiples of 3 and 8, we are looking at the 8 times table because it's larger. So 8, 16, 24, 32, 40, and 48. Those are the multiples of 8 that are less than 50. So now we've got those. Let's think which of these are multiples of 3. Well, the first one is 3 lots of 8, obviously. So 24 is going to work. And then, because we know 3 lots of 8 are 24, 6 lots must also go into the 3 times table. So that's going to be 48. 8, 16, 32, and 40 are not in the 3 times table. So it's just these 2 that make up the answer there. Question 15. This thermometer shows temperature in both degrees Celsius and degrees Fahrenheit. Work out what 25 degrees C is in Fahrenheit. Now, the way we can do this is we are given 20 equals 68. And we're also given that 30 equals 86. That is a given. So what this question is asking for is 25, which is the midpoint. So because 25 is halfway between 20 and 30, we can work out what it would be in Fahrenheit by working out what's halfway between 68 and 86. Now, to figure out what's halfway between a number, here's what we have to do. We have to work out the jump between them. So we have to do 86 take away 68 to start with. 6 take away 8, we need to do some exchanging. So that's going to be 7 there and 16. 16 take away 8 is 8. 7 take away 6 is 1. So the difference is 18 degrees Fahrenheit. But to find halfway, we need to half that difference, obviously. So half of 18 is 9. We have 9 that side and 9 this side. And the last thing we do then is 68 plus 9, which gets us 77 degrees Fahrenheit, must be the halfway point for 25 degrees C. Really interesting question now. I do like that one. Write the number that is 5 less than 10 million. So let's just write 10 million. And this is, again, just testing our place value, really. For 10 million, it'll be 10 followed by 6 zeros. I want 5 less. So it's going to be 9 million. It's going to be 900,000. It's going to be 999,000. It's even going to be 990 something. And then I want to take 5 off. So 5 ones come off, which leaves us 5 just there. Write the number that is 100,000 less than 6 million. Again, let's just write 6 million, just so we're very clear. 6 million is 6 followed by 6 zeros. And I want to take off 100,000. I want to take off 1 from here. Now that's 10,000, Mr. Price. What are you doing, Dylan? See, we can all make mistakes. And you know what? You will too. So let's just rub that out. We actually have to take off 100,000, which is obviously this column right here. The thing about taking off 100,000 is that it won't affect the ones or the tens or the hundreds. It won't affect the thousands or the 10,000s. It's just going to affect this column here and maybe the column after. In this case, it will. So think about it. 6 million is actually the same as 60 100,000s. So take 1 off. That leaves us with 59 100,000s. And that's the same as 5 million 900,000. So this is a very common question to get when we're taking away one lot of something in the place value where there's 0 and how it can affect other columns as well. Super. Question 17. Calculate the size of angles A and B in this diagram. Now, A is easy because when we have 2 lines, 2 straight lines that intersect, opposite angles are equal. So whatever we've got here is 160 is going to be the same as the opposite angle there. So I can put 160 in straight away. How do I work out B? There's a couple more steps. We need to know that the angles inside of a quadrilateral, a 4-sided shape, add up to 360. And we are actually, now we've worked out A, we've got 3 of the 4, so we can do this. We've got 160, and we've got 2 right angles. This is what this symbol means. We have to know this means 90. So 2 lots of 90 is 180, and we're going to add these together. And we get 6 plus 8 is 14. 1 plus the 1 that we've got for the 14 is 340. So what is left over? What do we need to have in this angle to make 360 in total? Well, I've already got 340. So the answer is going to be just 20 degrees, because 340 plus 20 is 360. And that gets us the total up there. So just to reiterate, these 2 squares mean 90, so that's 180. This is 160. There's only 20 degrees left to get to 360. Write the missing number. 70 divided by what is 3.5. Now, if I did 70 divided by 2, I'd get 35. And I need to get it 10 times smaller to make it 3.5. So what I need to do here is divide by 2 and divide by 10. And using that rule we spoke earlier about how factors help us here, we know that's the same as dividing by 2 times 10, which is 20. So 70 divided by 20 is 3.5. And we can check this out because we can do 20 times 3.5 to make sure it's 70. 20 times 3 is 60. 20 times 0.5 is 10. And that does add up to make 70. So good question there again, testing our knowledge of number. Miss Mills is making jam to sell at the school fair. Strawberries cost $7.50 per kilogram. Sugar costs 79 pence per kilogram. 10 glass jars cost £6.90. I can just tell this is going to be a long one. Look, 3 marks. There's going to be lots to do. She uses 12 kilograms of strawberries and 10 kilograms of sugar to make 20 full jars of jam. How much did that cost? Okay, well, let's just do this one step at a time. 12 kilograms of strawberries. So we have 12 multiplied by 7.50. Okay, cool. Let's just write this out like this. £7.50 times, and because I know my 12 times table, I can just treat it as a 12. 12 zeros are 0. 12 fives are going to be 60. So I have a 0 there, and the 6 goes down with a decimal place. 12 times 7 is 84, plus the 6 is 90. So it costs, the strawberries, they cost £90. Okay, cool. Next up, we have 10 kilograms of sugar. Thankfully, this is easier. 79 pence times 10 is going to be £7.90. I'm going to line these up because I'm going to add them up at the end. So the sugar, SU for sugar, is £7.90. Okay, cool. Because 790 pence is £7.90. And then 20 jars. So 10 glass jars cost £6.90. So we need 20. So that's going to be £6.90 times 2. So if I just do 2 lots of 7, that gets me 14. And take away 2 lots of 10 to account for that, that's going to be £13.80. So now we've got the individual cost of the strawberries, the sugar, and the jam. We're going to add these up to get our answer. 0, 9 plus 8 is 17. Put the decimal place in. 7 plus 3 is 10, plus 1 is 11. 9 plus 1 is 10, plus 1 is 11. And the total cost is £117.70. So then when she knows how much it costs to make, she knows how much she can sell it for, because she needs to sell 20 and make more than this to get a profit. Question 20. Here are two triangles drawn on coordinate axes, plural of axis. So we've got A and we've got B. Triangle B is a reflection of A in the x-axis. Two of the new vertices of triangle B are 10 minus 10 and 20 minus 30. What are the coordinates of the third vertex? Well, let's take a look here. If x is the line that it's reflected on, when we write a coordinate out, the first coordinate is the x-axis and the second coordinate is the y. So x is how far across we go, y is how tall we are. The thing about these reflected points, they're always going to have the same x because it's just reflected down. Then if we go across, we're on the y-axis now. If it's 10 high and we go down, it's going to be 10 low. So it's going to be 10 minus 10. Same for this one here. By the way, that's the first one, 10 minus 10. Then we have 20 minus 30. Well, yeah, look, if this is 20 minus 30, this one is still going to be 20 across the x-axis because we're going to the exact same point. And instead of 30 up, we go 30 down. So it's going to be minus 30. And you'll notice what happens here is the coordinates stay the same. It's just that the second value becomes negative. So let's look over here. Minus 1040. Well, this last one here, it's still going to be minus 10. It's going to stay the same. But what is the y value going to be? Well, it's not 40 up anymore. It's going to be 40 down because it's reflected. So it's minus 10 minus 40. And that's what we put in our answer here. Minus 10 minus 40. Hopefully you guys can follow that and see how that went. And that is the end of the test, guys. Did end with a tricky one there. But thank you so much for watching this far. And we'll be back with some more full SAT paper walkthroughs very soon. Make sure you like, make sure you subscribe, make sure you share to anyone who you think it would be useful. And I'll see you next time.